All right, guys, so we're going to continue the notes from yesterday. Okay, we're going to continue the notes from yesterday. On yesterday, we did intro to linear equations, and we talked about the things that we needed to know. The first thing that we need to know about a linear equation is that they graph straight lines. Not all linear equations are function. Vertical lines are linear equations, but they are not functions. Linear equations can be written in various forms. Um, the two forms that we talk about the most in this particular course is slope-intercept form, where you have equations that look like this in y equals mx plus b, where the number that's attached to x is the slope, and the number that has no variable attached to it is the y-intercept. And these are some examples of what they look like here. Sometimes you'll see B first, the y-intercept may come first, and then your slope and your x term might come second, but it's still written in slope-intercept form as long as you've isolated y. Y is on the side by itself. The standard form is where you have your x term plus or minus your y term equals the number that has no variable attached to it at all last. This first number cannot be a negative or a fraction. Just because it may not be written in standard form doesn't mean it's not a linear equation. It just means it's not written in standard form. Examples of what that looks like this, looks like this. Linear equations, equations that have constant rates of change, equations that have constant rates of change. To find the rate of change or the slope, there's two formulas for it. Remember that in a linear equation, slope is not going to change. It's not going to go from 5 to 7. It's going to stay either 5 the whole time or 7 the whole time. That's what makes it a straight line. Linear equations have starting amounts or y-intercepts. You need to know that the y-intercept is where the line crosses the y-axis, or in word problems, it's going to be the starting amount. Here, linear equations also have x-intercepts. Not all linear equations or straight lines are going to go through the x-axis or the y-axis, but they can. X-intercepts are where the line crosses the x-axis. Y-intercept is where the line crosses the y-axis. Okay, so now the sixth thing that we need to know about linear functions is that your x and your y, the meaning of x and y, okay, meanings for x is called your independent variable. And your meaning for y is your dependent variable. And I spelled this all wrong. Keep in mind that in most cases, your independent variable or the meaning of your x is time. It's hours, years, months, days, for the most part. Not all the time, but for the most part, the meaning of x is time. Your meaning for y fluctuates. That's the dependent. In order for you to find a value for y, in most cases, you have to know the value of x. So your meaning for x is called the independent variable. Your meaning for y is called the dependent variable. The dependent variable, for the most part, fluctuates. Your independent variable does not depend, your x values do not depend on any other variable. Time goes on regardless. Minutes are going to increase regardless. Hours are going to increase regardless. Time, for the most part, is always going to be your x value or your independent variable. Okay, so the last thing that we need to know, or that we're going to write about linear functions, is practical domain. Number 7, practical domain. The practical part is what makes sense, okay? Domain is talking about your x values. So when you see practical domain, or if a problem asks you for the practical domain, it's asking you for the x values that make sense in the problem. So the x values that makes sense in the problem. So if we're dealing with hours, it doesn't make sense to have negative amount of hours. The same for minutes, and the same for, let's see, minutes, hours, days. Doesn't make sense to have negative amount of hours. So your practical domain for hours would be greater 0 or greater than 0. Okay, so your practical domain are going to be the x values that make sense as it pertains to the problem. Okay, so now we're going to go over day 3. Though it says day 3, we're doing this on today. Doing day 3 today. Independent practice problems. So here it's saying, write, these are the equations here. These are linear equations, and you're going to write them in slope-intercept form. That's y equals mx plus b. And we talked about slope-intercept form in our notes. Okay, we talked about slope-intercept form in our notes. So we're going to do some problems where we're writing the linear equations in such a way that they look like this, where y is by itself, then you have the x term and the number that has no variable attached to it on the other side of the equal sign. So I'm going to go ahead and show my work at the bottom here. I'm going to do a couple, and then you're going to do the others on your own. So number 1, I have 3x minus 2y is equal to a negative 16. This is written in standard form, and we talked about what standard form looks like. It's where you have the x term, then the y term, then the number that has no variable attached to it is on the side by itself. The first number does not have a negative or a fraction attached to the x. So this is standard form. We're going to write it in slope-intercept form. So that means we're going to get y by itself. And you've done this before with literal equations. You're going to isolate y. So the first thing you need to move is the 3x. This is a positive 3x. So we're going to subtract 3x on both sides. When we subtract 3x on this side, it's gone, and we're left with the negative 2y. Bring down the equal sign. You can't combine these terms over here because they're not alike. So you can either bring down the negative 16 and then the negative 3x, or you can bring down the negative 3x first, then minus the 16. Doesn't matter which one you write first, as long as you take the sign in front of it. Lastly, to get y by itself, so that it's written in slope-intercept form, is to divide everything by negative 2. And you're dividing because it's the opposite of multiplication. The operation that's between this negative 2 and y is multiplication. Opposite of multiplication is division. Negative 2 divided by negative 2 is a positive 1, so that gives me 1y. Here, when I reduce this fraction, okay, a negative divided by a negative gives me a positive, so I'm going to leave it as a positive improper fraction as long as it's reduced. Positive 3 over 2x. I could change it into a decimal if I like. A negative 16 divided by a negative 2 is going to give me a positive 8. So I'm going to say plus 8. Now this is written in slope-intercept form. I'm going to do another one. I'm going to do number 2. Number 2, I have 13x minus 11y is equal to a negative 12. Okay. In order, this is in standard form because your x term is first, then your y term, your equal sign, then the number that has no variable attached to it, which is called a constant, is on the side by itself. The first number is that's attached to x is not a negative and it's not a fraction. So this is a linear function that is in standard form. So to write this in y equals mx plus b form, I'm going to isolate the variable y. So I'm going to subtract 13x on both sides. Okay. When I subtract 13x on both sides, this is gone, and I'm left with a minus 11y. Bring down the equal sign. I can't combine these two terms because they're not alike. So I'm either going to bring down the negative 12 first, or I can bring down the negative 13x first and minus 12. Doesn't matter which one you write first, as long as you take the sign with it. Okay. Lastly, to get rid of the negative 11 that's attached by multiplication, the opposite of multiplication is division. So you're going to divide everything by negative 11 on both sides. Negative 11 divided by negative 11 is a positive 1. So we got positive 1y. A negative divided by negative is a positive. So I'm going to reduce the fraction. It's already reduced. So I'm just going to keep it as an improper fraction. Or you can change it to a decimal if you like. A negative divided by a negative is going to be a positive. And I'm going to keep it as a reduced improper fraction. This is going to be my equation here. If you have questions, comments, or concerns, please make sure that you text me. And I need you to complete 3, 4, 5, and 6 today. 3, 4, 5, and 6. Have a great day.